Okay, this problem, this next problem we're going to discuss of complex number division is going to bring up quite a few topics that will be refreshers, okay? So let me copy this one down. Minus 2 minus 2i divided by minus 5 plus 2i. So we've got this expression, we've got to try to remove the imaginary component from the denominator without changing the value of the fraction. Okay, so I've written it down over here, and let's go ahead and see how we solve this. There is a special technique, and it's called multiplying by a complex conjugate. Okay, you may remember complex conjugate is how you change a complex number that is in the form a plus bi into a minus bi. In this case, a minus bi is the complex conjugate of a plus bi. The technique for solving this problem is to multiply both the numerator and the denominator, of course, by the same number. That way we're not changing the value. And we choose the number so that it is the complex conjugate of the denominator. That always removes the I component from the denominator. So the complex conjugate of this denominator occurs when we change the sign in front of the imaginary component. So instead of, we're starting with negative 5 plus 2i, our complex conjugate is negative 5 minus 2i. So we need to multiply both numerator and denominator by negative 5 minus 2i. The rest of the solution is simply an exercise in simplifying. Okay, now I could multiply the denominator using FOIL or using many different methods that are all valid and will all work. However, what I am going to suggest we do in this case is to use a fact known in geometry, which is that a plus b times a minus b is equal to a squared minus b squared. So in other words, this multiplication is of the form a plus b here and a minus b here. So we can calculate what the denominator will come out to be, because it will come out to be negative 5 squared. Okay, a squared minus, and then we have b squared, which is 2i in this case squared. That's kind of a shortcut to getting to the denominator. Unfortunately, the numerator does not give us a way to get to the shortcut. So let's go ahead and at least simplify our denominator. So we've got negative 5 squared is 25. Negative 2i squared is going to be negative, because we're not doing anything with a negative, 4i squared. We can go ahead and we can simplify 4i squared. I squared is negative 1. Times 4 makes it negative 4. So we have 25 minus a negative 4, which is the same thing as 25 plus 4, 29. So we know our denominator is going to be 29. So that's, we've got something going on there that we've already solved. So let's go ahead now, and we've got to do some tedious multiplication to get our numerator. So our numerator is negative 2 minus 2i times negative 5 minus 2i. Negative 2 minus 2i times negative 5 minus 2i. You notice I'm going to sort of multiply this longhand. I could do it using FOIL, but I'd like to review longhand multiplication with you as well. Let's go ahead and let's actually multiply it out term by term. Negative 2i times negative 2i is positive 4i squared. Negative 2i times negative 2 is 4i. Negative 5 times negative 2i is 10i. And negative 5 times negative 2 is positive 10. So this is going to be, when we add this up, we're going to get our numerator. We already said earlier 4i squared is negative 4. We've got 10 here, and we got 14i over here. So let's go ahead and let's simplify what we've got. And when we simplify it, we combine like terms. 10 minus 4 is 6. We have 6 plus 14i in the numerator. And so if we go back to our problem here and we put 6 plus 14i in there, 6 plus 14i like such, we have our solution. So the answer to the problem is 6 plus 14i over 29. Well, I think that's enough for a video on its own, and we'll resume with part 4 of the crash course next.